Okay, hi. This is 2016 TYS Combined Chemistry Paper 3 Section B. Okay, iron from blast furnaces is usually mixed with other elements to form alloys. Name one of these alloys and give a reason why this alloy is preferred to iron from blast furnace. So there are many alloys that we have covered during the lesson. So in the mind map, these are the alloys that we have covered. I ask you to remember brass, stainless steel, steel and bronze. So you can give any one of this. Okay, so let's say you put steel. So steel is an alloy and give a reason why this alloy is preferred. So this part requires you to recall the properties of alloy. So properties of alloy, they are all here. Hard, strong. So in this case, if we compare steel and iron, that would be hard and strong. So you can just say steel is harder and stronger than iron. Okay, that's it. That's the 2 marks. Okay, in part B, in a blast furnace, explain, including chemical equations, how iron is extracted from the ore. And also impurities are removed from the ore. Now this is a 4 marks question, 4 marks each. Which means that you should not be just explaining carbon monoxide as reducing agent. It reduces iron 3 oxide to iron. Okay, so instead you should be explaining all the equations. Okay, remember in the blast furnace there are 5 chemical equations. So it starts out with the limestone decomposed to form quicklime as well as carbon dioxide. So these are the 5 chemical equations that I talk about. The first one is a thermal decomposition of limestone to form quicklime and carbon dioxide. Then after that, the carbon burns in the air. The carbons from the coke burns in the air to form carbon dioxide. So over here you have a lot of carbon dioxide. So what is this carbon dioxide for? The carbon dioxide will react with the carbon from the coke to form carbon monoxide. And this is exactly this carbon monoxide which is responsible to reduce iron 3 oxide to produce iron, which is our intended product from blast furnace. So these 4 chemical equations as well as the 4 short descriptions of the chemical reactions, you need to write it down in order to answer part 1. Iron is extracted from the iron ore, in order to secure these 4 marks. Now for part B, impurities are removed from the iron ore, and that would be the last chemical reaction in a blast furnace, which is a quicklime from the decomposition of limestone. Is used to reduce acidic impurity in the form of sand to form calcium silicate or slag. And since this one is a 4-mark question, you probably need to explain a little bit about this slag. So the slag will float above the molten iron. Okay, the slag will float above the molten iron in a blast furnace, at the bottom of the blast furnace where it is being removed to pave road. Okay, so basically that's all you need to explain for part B. Okay, this part as well as this part. Alright, that would be for question 8. So remember, when you're answering the questions, you have to look at the number of marks allocated to it so that you know how much to write about. Alright, for question 9, it's about ethanol. Now, ethanol can be made in a laboratory at room temperature. Name the process, list the substances needed, and write a chemical equation for the preparation of ethanol at room temperature. Now, this question again, it is very content based. Okay, there is no surprises, no twist and turn. It is taken right out from the textbook, and in the mind map also it is available. So in the mind map, that will be this part. Okay, fermentation is the name of the process. So basically what it does is that the enzyme from the yeast will break down the carbohydrate from the glucose to form ethanol and carbon dioxide, and this is the chemical equation. Okay, so basically for this question, all you need to do is to name the process, which is fermentation. Okay, list the substances needed. What are the substances needed? The substances needed would be glucose as well as yeast. Okay, the substances needed. I'm just going to write it down in point form. And the chemical equation would be the chemical equation that I show you just now. Is right in the mind map. C6H12O6, which is the chemical formula for glucose. And the enzyme from the yeast will break it down into ethanol, which is C2H5OH. How do you know ethanol is C2H5OH? Remember ethanol? You must remember the ethanol is an alcohol. So alcohol, the general formula is CnH2n plus 1 OH. And F means there are two carbon atoms. So the N is 2. So C2H 4 plus 1, which is H5OH, C2H5OH, plus carbon dioxide. And you have to balance the chemical equation. And if you balance it, you will get something like this. So over here, you can write down yeast. Okay, enzyme from the yeast will break down the glucose molecules to form ethanol and carbon dioxide. Okay, so that's all about it. 5 marks. Okay, seems a lot, but the answer seems quite short. 1 mark each for fermentation, glucose, yeast, chemical equation, 2 marks. Okay, state why the temperature of the reactants must not be allowed to rise much above 45 degrees Celsius. Because as you can see over here, okay, required conditions for fermentation, temperature 37 degrees Celsius. Otherwise, the yeast will die and the fermentation will stop. So, in fact, it is because the enzyme from the yeast will be destroyed. So, you can just say enzyme from yeast will be destroyed. No need to write your answer in complete sentence. No need to say will be destroyed above 45 degrees Celsius. In fact, it will start to be destroyed above 37 degrees Celsius. Yeah. Okay, no need to write in complete sentences. Like this will do. Okay, for part B, an organic acid is formed when propanol, an alcohol, is left open in air. Is left open to the air. Left open to the air, what is in the air? Oxygen. That means this oxygen and alcohol will react to form what? Alcohol and oxygen will react to form what? That is the questions for this part. So you can try to recall the reactions that alcohol undergo. Okay, again from the first page of our mind map, we know that alcohol undergo 2 reactions: combustion and oxidation. And oxidation, when alcohol reacts with the oxygen in the air, it will form carboxylic acid. So in this case, ethanol will form ethanoic acid. Okay, so draw the structure of propanol, showing every atom and every bond. So propanol, this is propanol, not ethanol. So propanol, again from what is the chemical formula for propanol? CnH2n plus 1 OH. This is the general formula. So propanol, the word prop would be how many carbon atom? Okay, prop is 3 carbon atom. So the N is 3. That will be C3H7OH. So C3H7OH. This is the chemical formula. But the question says draw the structure. So this structure refers to structural formula. So structural formula, 3 carbon atoms. So you just draw 3 carbon atoms in straight line. Try not to draw, in up and down, vertically. Try to draw horizontally. So 3 carbon atom, and then the functional group is OH. So draw OH, and then the rest would be just hydrogen atoms. Okay, after drawing, remember every time I ask you all, after drawing the structural formula, always check the number of bonds that each atom should have. For example, carbon should have, the electronic configuration is 2,4. So each carbon atom should share 4 pairs of electron, which means that around each carbon atom, there must be 4 bonds, 4 lines. One line represents 1 bond. So each carbon atom 1, 2, 3, 4. Each carbon atom 1, 2, 3, 4. Each carbon atom 1, 2, 3, 4. 4 pairs of electron or 4 bonds. And each oxygen atom electronic configuration is 2, 6, meaning that short of 2 electrons. So meaning that each oxygen atom should share 2 pairs of electron. That means 2 lines. Okay. And for hydrogen, of course, each hydrogen atom should share 1 pair of electrons. Okay, so after drawing the structural formula, you have to check all these things. Check the number of bonds or the number of pairs of electrons that each atoms should share. So this is correct, propanol. Another thing to check would be to check the structural formula against the molecular formula. Okay, C3H7, C3. So there should be 3 carbons, and then H8. There are 8 hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8. And then oxygen is 1. So it's correct. Now suggest the formula of the organic acid. Explain with reason. So the formula of the organic acid would be, this is propanol, right? When you oxidize propanol, you get propanoic acid. Just like in the mind map, you oxidize ethanol, you get ethanoic acid. So you oxidize propanol, you should get propanoic acid. Now, let's tackle this part first. What is the formula of propanoic acid? So this organic acid would be propanoic acid. What is the formula for propanoic acid? So you need the general formula of carboxylic acid. General formula for carboxylic acid is CN, H2N plus 1, COOH. Okay? And then for propanoic acid, now remember, the word prop means 3 carbon atom. 3 carbon atom, does it mean that N is 3? It is not, because there is 1 carbon atom here. So there should be, so this N should be 2. So that 2 plus 1 become 3 carbon atoms. So the N should be 2. When the N is 2, the formula would be C2 H 2N plus 1, that will be 2N plus 1 is 5 COOH. Yeah, this is the formula for propanoic acid. Explain with reasons why the propanol has been oxidized or reduced. Now, if you compare these two, this is propanol, this is propanoic acid. What is the difference? The difference is this one one oxygen atom, this one 2 oxygen atoms. So propanol has been oxidized because it gains 1 oxygen atom to form propanoic acid. Okay, so you can write down here, propanol has been oxidized as it gains oxygen to form propanoic acid. That would be the answer for this. Okay, so that's for number 9. Well, again, 4 marks. 1 mark for the structural formula, 1 mark for the formula of the propanoic acid, 1 mark for oxidized, 1 mark for the reason. Alright, let's look at number 10. Draw dot and cross diagram. So this is bonding, chemical bonding chapter, to show the arrangement of electrons in the molecules of hydrogen and water. Now remember, before you draw dot and cross diagram, what must you have? What must you do first? You must write down the electronic configuration. Hydrogen is 1. Now remember, to write down the electronic configuration, you have to look at the periodic table and look at the proton number. So hydrogen is 1. Water is H2O, right? H2O, and the oxygen would be 2,6. Okay, write down the electronic configuration first. Molecules of hydrogen. Molecules, that means H2. So this one is H2. So molecules of hydrogen, simple. Remember, when you draw the dot and cross diagram, try to draw it big and must use pencil. Must remember, must use pencil. Okay, so this would be hydrogen molecule. And then for water, and one more thing is that the questions just say draw the dot and cross diagram without specifying whether you should only draw the valence shell or not. So you have to draw all the electron shells. So oxygen, okay, oxygen, there are 2 electron shells, and then you have hydrogen, okay, actually this part is not good. The intersection area must be big enough so that it is very clear and without doubt. This is actually not very good, but since I'm using red pen, I can't erase it. Okay, but you, since you're using pencil, you must use pencil and you should improve on this. Okay, so oxygen 2,6, so there are 2 electrons here. That means outside you should have 4 more. Okay, so after you have drawn the dot and cross diagram, you must, okay, inner shell must have another 2. You must double check. How do you double check? You must cover the hydrogen. Only look at the oxygen. Oxygen is it 2,8? Because after sharing electrons, it must be stable. Is it 2,8? 1, 2, 3, 4, 5, 6, 7, 8. Correct. And then out of the 8 electrons in the outer shell, 6 of them must belong to the oxygen atoms. So 1, 2, 3, 4, 5, 6. Because in this case, I use X, I use the cross to denote the electrons for oxygen. And then for hydrogen would be 2. So it's correct. Okay. Okay, now for part 2, explain why knowledge of the electron arrangements in helium and neon is important when drawing dot and cross diagrams for hydrogen and water. Now basically you have to relate the electron arrangement, that means the electronic configuration of helium and neon, to that of hydrogen and water. Now if you look at helium, what is the electronic configuration? Okay, look at the periodic table. Electronic configuration for helium is 2. Alright, because the proton number for helium is 2. How about for neon? For neon, the proton number is 10, which means that electronic configuration is 2,8. So can you see the similarity? Helium and hydrogen. Hydrogen is here, see? 2 electrons. How about neon? 2,8. 2,8, is it similar to oxygen? 2,8. Yeah, so which means after the hydrogen atom has shared a pair of electrons with the oxygen atom, the hydrogen atom achieved the electronic configuration of helium. And then, likewise for the oxygen atom, after it shared 2 pairs of electrons with hydrogen atoms, it achieved the electron arrangements of neon, which is 2,8. Okay, so I'm just going to write down in short form. Okay, hydrogen atom achieves electronic arrangement. Since the question used electronic arrangement, I also use electronic arrangement. Achieves electronic arrangements of helium after sharing a pair of electrons. And likewise, the oxygen atom also achieve electronic arrangement of neon after sharing 2 pairs of electron. Yeah. So this question is trying to get you to relate electron arrangements of helium with hydrogen, and also between neon and oxygen. So after sharing electrons, the hydrogen atom would achieve electron arrangements of helium, and oxygen atom would achieve electron arrangements of neon. So that's basically what the question wants. Now for part B, gaseous hydrogen chloride dissolves in water to produce two different ions. Now remember, hydrogen chloride is HCl. When HCl dissolves in water, what does it form? It forms our familiar, our good friend, hydrochloric acid. Okay, and hydrochloric acid consists of two different ions, which is hydrochloric acid. What are the two ions? H plus and Cl minus. So the two different ions will be H plus and Cl minus, or hydrogen ion and chloride ions. Give the chemical formula of each ion. There will be H plus and Cl minus. Predict the approximate pH of the aqueous solution that is formed. So the aqueous solution that is formed is hydrochloric acid, and the pH of hydrochloric acid, all these are hydrochloric acid, nitric acid, sulfuric acid, all of them are strong acid, and strong acid the pH is 1. If you write 2, I think it's correct as well. Explain why the aqueous solution of hydrogen chloride can be neutralized by adding an aqueous solution of hydrogen of sodium hydroxide. See, this question is related to the previous parts. Yeah, because aqueous solution of hydrogen chloride basically produces H plus ion, and then sodium hydroxide produces OH minus. So the neutralization, it's about H plus and OH minus ions react to form water. So H plus ion from HClAq reacts with OH minus ions from NaOHAQ to form water. I mean, if you want further information, it's actually from the ionic equation, and this is the ionic equation. H plus plus OH minus to form H2O. But this ionic equation is not needed. This is just for information. Remember, this is the ionic equation for all the neutralization reaction. Alright? So that's basically all about 2016 TYS Combined Chemistry Paper 3 Section B. And remember, always reserve 25 minutes, at least 25 minutes to do Section B. So Section B only need to do 2 questions, 20 marks, 10 marks each. Try to reserve 25 minutes to do it. Alright, thank you for viewing. Goodbye.